This is the third and final video looking at the relationship between feedback and parking ability. So in the last video, we went through the sums of squares, degrees of freedom, mean square, and F. And we're going to start this video with putting together the ANOVA summary table. So just like always, the ANOVA summary table has these 5 columns: source, sum of squares, degrees of freedom, mean square, and F. And then you have to figure out what the rows are going to be. So the rows, the easiest way to do this is to go back to your sums of squares and look at the little labels to see what kinds of sums of squares you calculated. And we calculated an A, an S over A, and a T, and so those are going to be our rows. And all we need to do now is go back and look at the numbers that we calculated, and we're going to fill those numbers in to our ANOVA summary table. So our sum of squares A was 52.67. Our sum of squares S over A was 8, and our sum of squares T was 60.67. Our degrees of freedom, A was 2, S over A was 9, and T was 11. Our mean square, A was 26.34, S over A was 0.89, and our F ratio was 29.6. All right, so nothing magic here. All I did was I transferred the numbers from the previous video into the ANOVA summary table. So now the kind of the final step of the problem is to evaluate our F ratio. So we've got this F of 29.6. What does that mean? Does that mean that feedback affects parking ability or not? Certainly, if we look at the means, it looks like there might be something going on here, right? These people who got bad feedback, it looks like it took them a bunch of times to back up, but we don't know from looking at the means. We have to evaluate this F ratio. So the first step in evaluating F is to come up with our hypotheses. So remember, our null hypothesis is there is no treatment effect. Right? And remember, there's lots of different ways to say this. You could also say the means are equal. So you could also say the means are equal. All right, those two phrases mean exactly the same thing. And you could also say the same thing using the mu's. So mu1 equals mu2, and in this case we've got 3 groups. So if you're going to use the mu's, you have to have the right number of groups in here. So mu1 equals mu2 equals mu3. All 3 of those statements mean the same thing. If I ask you to write a null hypothesis, any one of those would suffice. The alternative hypothesis is exactly the opposite. So whatever we set up here, we're going to reverse it for the alternative. So the alternative hypothesis is there is a treatment effect. So there is a treatment effect. We could also say the means are not equal. And if we want to use the mu's, we could say mu1 does not equal mu2, does not equal mu3. Again, all 3 of those statements are interchangeable. You can use any of them. If I ask you for a null or alternative hypothesis, any of those will suffice. So next, we're going to do our research hypothesis. And the research hypothesis, we're going to talk about the relationship between these actual variables. So notice when you write the null and alternative hypothesis, what's missing up here is mention of your actual variables. And for my class, I don't want to see the actual variables when you talk about the null and the alternative. I really want you to write it this very kind of cut and dry, memorizing the ways of saying it. Research hypothesis is where I want you to talk about your actual variables. So looking at this, we're doing this relationship between feedback and parking. I might predict that feedback affects parking. All right, feedback affects parking. I might predict that feedback doesn't affect parking. And I might go into something a little more specific. I might say people that get bad feedback will take the most times backing up. I might say good feedback results in the best parking ability? I can say this lots of different ways. The important thing is that I mention both my independent and my dependent variables. So somewhere in that hypothesis, I want to be mentioning both variables. All right, so once we've written our three hypotheses, now it's time to actually evaluate the F ratio using our critical F. So we're going to look up our critical F in the critical values table, the critical values of F table. And remember, how we do that is we're going to go back to our F ratio, which in this case was mean square A over mean square S over A. And we are going to look at what was on the numerator and the denominator of that F ratio. So the numerator was A, so the first degree of freedom is degrees of freedom A. The denominator is S over A, so the second degree of freedom is degrees of freedom S over A. So when we're using that chart, we're going to go over to column 2 and down to row 9. All right, so I have a table here. It's not the one in the book, but we're going to go over to 2 and down to 9. Over to 2, down to 9. And when we do that, we will get a critical F of, I did not do that right, we are going to get a critical F of, actually, I'm going to write it down here. We're going to get a critical F of 4.26. All right, our critical F is 4.26. Okay, so critical F is 4.26. Now we are going to go back to our ANOVA summary table and look at our observed F. And we're going to plot our observed F on this chart. So the critical F is 4.26, the observed F is 29.6. Does that go to the left or the right? Hopefully you can all see this with me. It goes to the right. And remember, when the observed is to the right, right is reject. So our decision is we are going to reject the null hypothesis. Null hypothesis says there's no treatment effect. If we reject it, our conclusion is there is a treatment effect. Another way of saying that is that the means are equal. And if I ask you to draw a conclusion in terms of the actual, another way of saying that there is a treatment effect is that the means are not equal. I think I misspoke there. So when we reject, it means there is a treatment effect, which means that the means are not equal, which means that there is something going on. So in this particular problem, when we're looking at the relationship between feedback and parking ability, if we reject the null hypothesis, it means feedback affects parking ability. Okay, I'm going to go through that whole thing one more time just to make sure that I did not misspeak. So our critical F is 4.26, our observed F is 29.6, which is to the right. When our observed F falls to the right, we reject the null hypothesis, which means there is a treatment effect, which means that the means are not equal, which means in our problem, feedback does affect parking. So in terms of journal format, our journal format is F. In parentheses, we put our degrees of freedom, 2, 9, equals our observed F, 29.6. And because we rejected, it's P less than or equal to 0.05.